Now we'll start with the topic of second law of thermodynamics. Before proceeding to second law of thermodynamics, you must be aware about some facts about the heat flow and transformation of heat. The very first thing you should know always is heat flows from high temperature to low temperature region all by itself. Say if two bodies, one is at high temperature and other is at low temperature, are connected via a thermally conducting media, then automatically heat will flow from high temperature region to low temperature region. Another fact is mechanical energy can be converted to heat and vice versa. A very common example which you have already covered in your early classes is friction. Whenever some work is done against friction, that amount of mechanical energy is transformed to heat. As far as thermodynamic systems are concerned or gaseous systems are concerned, we can analyze this transformation of work to heat can be understood with the help of a simple illustration. Say, to understand this, we consider a piston cylinder system in which a gas is trapped below a piston, and this cylinder in which the gas is trapped is made up of thermally conducting media. And say if in this situation we push it with a force externally and the piston is pushed down. So in this situation we can say if this piston is displaced by a distance x, work is done by an external agent onto the gas. So when this mechanical work is supplied, it will increase the internal energy of gas. That means the gas temperature will increase, and if its temperature is more than the surrounding temperature, it will reject heat to the surrounding. So we can state if W is work done on gas and delta U is increase in internal energy and Q is heat rejected, then we can directly state by energy conservation. In magnitude, we can write W is the total work done, which is equal to increase in internal energy plus heat which is rejected. However, we are using here only the magnitudes of work done, internal energy and heat, and this is even valid according to first law of thermodynamics. We can write Q is equals to delta U plus W. Here work is done on the gas, so this is negative. Internal energy is increasing, this is positive, and heat is being rejected by the system, this can be taken negative. So in this situation, this W can be taken on left hand side of equality and Q can be taken on right hand side of equality. This will become the relation which is valid according to energy conservation. So in this situation, whatever work we are doing, a part of that mechanical energy which is supplied to the gas by the external agent is being transformed into heat. So always remember, these are the two basic facts which will form the basis of second law of thermodynamics. We'll discuss about second law of thermodynamics in detail now, but you must be aware about both the things. Similar to this analysis, we can also discuss about conversion of heat into work, which is a very common phenomena as far as the first law of thermodynamics is concerned. This we already studied in detail in various processes. Like if we are having a piston cylinder system and a gas is trapped in it, and if externally a heat Q is supplied to it, a part of this heat raises its internal energy, so we can say its delta U is positive, internal energy increases, and the piston is displaced up. That means here we can say that gas is doing external work on the piston or work is being done by gas on atmosphere, because atmosphere is being compressed. So your work done by gas can be taken positive. And we can say heat, a part of heat supplied is used in doing work on external system by the gas. So here we can write by first law of thermodynamics, which we have studied, Q is equals to delta U plus W. Here Q is positive, delta U is positive, and W is also positive. So by using a normal gaseous system, a part of heat can be transformed to work. And if work is done by an external agent, a part of that amount of work will be rejected. It may be rejected by the gas to the surrounding also. So these are the basic facts which we must know, that heat can be transformed to work and work can also be transformed to heat. Along with this, the very first fact which we have studied is, in general, heat flow takes place from hot region to cold region, or from high temperature region to low temperature regions. Let's discuss about the details of second law of thermodynamics and its statement. Now we are going to discuss that. Now to understand this second law of thermodynamics, we define this law in concern with two different type of cyclic processes. First, we'll analyze heat engine cycle, and the other we define with the refrigeration cycle. Now, second law of thermodynamics will define based on both of these cycles, heat engine cycles as well as refrigeration cycles. And if we just write down the statements of second law of thermodynamics for these two, as I think you can recall when we have studied about cyclic processes, both the cycles we have studied, and heat engine cycles are those which are used to transform heat into work, and refrigeration cycles are used to basically transform work to heat, or more precisely we should say refrigeration cycles are used to transfer heat from cold regions to hot regions. All of you know what exactly a refrigerator does. There is a chamber in refrigerator which is having a temperature very less compared to that of surrounding temperature, because by doing some work by its compressor, we transfer heat from its chamber to the surrounding. Anyway, we are going to discuss about the statements of second law of thermodynamics, and then we'll analyze the details of heat engine cycles and refrigeration cycles. So, if we talk about statements of second law of thermodynamics, it is given in two ways. The very first statement is it is impossible to transform 100% heat into work. And the second point is it is impossible to transfer heat from colder region to hotter region without doing work, without doing external work. So we'll analyze both of these statements in correlation with the heat engines and refrigerator cycles step by step in detail.